We'll proceed in vector and commercial calculus. Okay, probably we'll change the discussion to case study and I'll try to make it end today if possible. Vector and commercial calculus, in that term, we are calculating flux density from flux and then flux from flux density. Flux means if there is a liquid passing through a surface, if there is a Okay, if there is a liquid that is passing through a surface with a velocity, then how much is the volume liquid is coming out of the surface? That is velocity vector, velocity of the liquid, velocity vector dot product with the area vector. That is called flux. Okay, if it happened to be a closed surface, if I am saying like this, then this is open surface. This can be a closed surface. Okay, like this is a closed surface. If this is a surface, if I make it like this, then it is a completely closed surface. Like this is a closed surface. Okay, if I keep it like this, then velocity of the liquid that is passing through this and it is coming out of this. Flux is out of the surface. If this is a single surface, then out of the surface. Surface is oriented this side. Okay, how surface is oriented? That is the question. Where is your surface vector? Anyone would ask, where is your surface vector? If this is your surface, then surface vector can be in this direction, surface vector can be in this direction. So my surface vector is in this direction. So someone can say this is the upward of the surface. Surface vector is in this direction. If that is the case, then the liquid is coming and passing through this, coming out of here. So what is out of here? Like that, if I mold it like this and make it a sphere, then all around it, the surface vector is outward. If here, surface vector is this one, not this one. This is inward, inner region. This is outer region. So liquid is coming and coming out of the outer region. That is the flux. If I make it a sphere, then how much is the liquid that is coming out of it? If I say that full liquid is coming out of it, means liquid source is inside this. If liquid source, the source of the liquid can be electromagnetic radiation, liquid can be electric radiation, magnetic radiation. So instead of radiation, I say it is a liquid. If I say if this is a closed surface and liquid is coming out of it or from everywhere where the area vector is outward, everywhere area vector is outward, then someone will say certainly your liquid source, the source of this is inside this sphere. That's why it is oozing out from all directions. Then flux is highly positive. But if energy source is this direction and then energy source is going like this, then from some side it is entering into it, from other side it is exiting into it. The side from which it is exiting, that side, surface area vector is along the velocity vector. But surface area vector, since this surface area is outward, everywhere surface area vector is perpendicular to the surface. But if I see this side, then it is opposite to the velocity of the liquid. Velocity of the liquid is going like this, but surface area vector is opposite to it. But this side, surface area vector is in direction of velocity vector. So this side, the net flux, net volume of the liquid that is coming out of the surface is velocity vector dot product with the surface area vector. If that is the case, then this side the flux will be positive, whereas this side the flux will be negative. If you add this, then how much is the flux net that is coming out will come into the picture. If net flux coming out from here it is negative means more liquid is entering into it and less liquid is coming out of it. Flux is negative. Okay, flux can be negative. Okay, if flux is positive, if flux is positive, means less liquid is entering and more liquid is coming out. Now we came as whatever is the flux of this, divide it by the volume is the flux density, or see the change in the velocity. If velocity that is entering and velocity that is coming out, if velocity is coming out is more than entering, then d velocity by this, the change in velocity is seen along the path. If I take three orthogonal, if this is the velocity, it has x component, it has y component, it has z component for the velocity. Any vector in vector form is represented through orthogonal component only. X-axis, what is its x-axis? What is its y-axis? What is its z-axis? Now add it. Xi plus yj plus zk, that is the net vector. No, my vector is f vector. Yeah, that is f1i plus f2j plus f3k. Same thing. Okay, if that is the case, then first is flux density. How much is the flux coming out of it? Divide it by the volume. Or how much is the flux that is entering and exiting? How much change in the velocity that is entering and exiting? How much change in the velocity that is seen along the path? That is same as velocity, x component of velocity change along x-axis plus, that is df1 by dx plus df2 by dy plus df3 by dz. How much the x component of velocity vector is changing along x-axis, y-axis, z-axis. That is called divergence. Same thing, flux density and divergence, they are exactly same thing. They are exactly same thing because flux density is how much is the net flux coming out of the surface, divide it by the volume. It give anyone sense. If it is positive, then it gives a sense that there is a there is a liquid source inside it. That's why the net radiation coming out of it is positive, or there is a hole inside that, that net radiation is negative. If I'm talking about there is a liquid that is coming out of from here and then it is gaining the velocity, then only flux is growing. If flux is growing, means there is energy source inside it. That's why flux density is positive. Or velocity is changing inside it in a positive manner, all along three directions. That is also called, it is also called kind of divergence, that is positive. df1 by dx plus df2 by dy plus df3 by dz, where f1, f2, f3 are the x, y, z component of the velocity vector. That is also called divergence or net flux divided by the volume. Now we came to a problem where if the flux of the, if I know the divergence of a velocity is zero, divergence of a velocity is zero, then net flux coming out of any closed surface is also zero. Divergence of a velocity vector is zero. If divergence of a velocity vector is zero, how it is zero? If I say there is a liquid that is going in a f direction, f has f1 component along x-axis, f has f2 component along y-axis, f has f3 component along z-axis. If divergence is zero, means f1 is changing along x-axis plus f2 is changing along y-axis plus f3 is changing along z-axis. If I add all these three changes at a particular point, net will be zero. That is, the divergence is zero. Like many times I have given example minus xi plus yj plus zk. Divergence is 1, it is not 0. Minus xi means velocity is going towards origin. If I am talking about divergence at the origin, means velocity or the liquid is coming toward origin. That's why it is minus xi plus yj. It is going outward of y-axis, it is going outward of z-axis. That is 1, or minus xi plus y by 2j plus z by 2k. Whatever liquid is coming at the origin from the x-axis, half of it is going in y-axis, half of it is going in z-axis. There is no energy source kept at the origin. Divergence is 0. Otherwise, minus xi plus yj plus zk divergence is 1. There is energy source kept at the origin. Whatever is coming from the x-axis, complete liquid is going along y-axis. But still liquid is going on z-axis, means there is an energy source kept at the origin. That's why divergence is there. If this is this condition, if this is the condition, now consider divergence of a velocity vector is 0. Then prove that if there is a velocity, there is a liquid that is coming and it is hitting a closed surface, net divergence out of this surface is zero. That is what we are trying. Okay, net diver, if we are calculating net flux is same as divergence into the volume. Divergence into the volume, that is the net flux. The flux density or divergence is flux divided by the volume. Similarly, that is getting the flux density from the flux. Getting flux from the flux density or divergence is integrating divergence of flux density with the volume, or flux density or divergence into the volume is the net flux if it is integral calculus. If flux density is algebra and there is independent component and dependent component, then flux density into volume, rather than we say flux density into d of the volume, whatever it is. Flux density into the volume is the net flux. If I know flux density at a particular point, and if I make a closed surface around it, and flux density is zero, then net flux that will come out of the full surface will be zero. Anyway, net flux that will come out of the surface is flux density dot product with d of volume. I'm sorry, it is a scalar. Flux density into d of volume. Flux density is zero, the net flux is zero. We were trying to prove that if flux density is zero, then net flux will be zero. Net flux calculation is velocity vector dot product with the area vector. Velocity vector dot product with the area vector. That is the net flux. Now velocity vector dot product with the area vector. How? How? Now let's go deep on it. Anyway, we have seen divergence of a velocity vector is zero, means df1 by dx plus df2 by dy plus df3 by dz, like minus xi plus y by 2j plus z by 2k, minus xi is minus 1, df1 by d1 dx 1 by 2, 1 by 2, net is 0. So if it is algebraic vector, then divergence can be 0, which all three components they add together and it becomes 0. Or the net velocity vector is a constant vector at all, like ai plus bj plus ck, where a, b, c are a numeric number. Then df1 by dx2 a constant, all are 0, 1. So if I say my divergence at a point, divergence of velocity vector is 0, then I consider velocity vector is a scalar vector only, numeric vector only, because there also it is 0. If that is the case, then a scalar vector dot product with the area vector of a closed surface must be 0. This one I have to prove. I really don't know how to prove it. So I went to the 2D. In 2D, I try to do same thing. If I take a scalar, if I take, okay, someone can grow in 3D. No one has stopped. Okay, if I have three dimension and if I have a, if I anyway, in last video we have proved it that if there is a scalar vector ai plus bj plus zk, and this scalar velocity vector is passing through a sphere is centered at the origin, then certainly it is 0. Someone can try cubical reason. Place a cube of side 1, 1, 1 at the centered at the origin and make a dot product of ai plus bj plus zk with the area vector. Okay, and see the integration of the full three sides, x equal to minus half to half, y equal to minus half to half, z equal to minus half to half. It should be 0. Or for any closed surface, it should be 0. I take two dimensions. Now, rather than a sphere, consider there is a closed line. If there is a closed line, there is a algebraic vector, there is a constant vector, that is ai plus bj, where a and b are numeric. ai plus bj, where a and b are numeric. So this is a numeric vector. Numeric vector means everywhere, if this is x-axis and this is y-axis, ai plus bj, if this is numeric vector, everywhere they are, the direction of this vector is independent of x-axis. You take anywhere, it will be parallel. This is numeric vector. But if I take xi plus yj, depending upon the x value or y value, the vector will keep changing. That is variable vector. This is static vector. If I do dot product of a static vector along this line, along a closed line, if I am taking dot product of a constant vector along this complete surface, this is what we are trying to calculate the flux, the velocity vector or vector field dot product with the area vector. Now this velocity vector, I am changing it to two dimensions, ai plus bj. Surface area vector, instead of that, I have a line vector. This is line vector. Okay, this is position vector of the surface area. This is line vector. Now what we are trying to do with this dot product? Dot product means if I have a constant vector, dot product with the line vector along a closed loop. Consider this constant vector is along y-axis. This is x-axis. This is y-axis. If I do dot product with the line vector, now at this point the line vector is like this. Line vector is along the line only. This is the line vector. This is here. The dot product will be 0. But as line vector is changing here, line vector will come exactly in the direction of of the the velocity vector. So all the while here first dot product is 0, but dot product will be non-zero, 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 non-zero. Here dot product of this line vector and velocity vector will be maximum because they are in the same direction. Okay, dot product, what we are trying to do? Okay, if I say that if this is displacement vector and this is consider this velocity vector is a force vector. If this is a force vector and this is displacement vector, then if I do dot product, we are getting the work done. Work done is for, or dot product of any two vector is this vector dot product along this direction. How much is this vector essence in this direction? That is dot product. If it is at 90-degree, then this vector, there is no component along this axis. Dot product is 0. If this force vector is this and displacement vector is this, then dot product is maximum. But as force is going like this, then dot product is becoming less. This into cos theta. Less, 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 less. Here it started becoming negative now. This magnitude, this magnitude and cos theta, negative, 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 then positive, 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 positive. Anyway, I have taken a circular. If I take any closed loop, then looks like this first quadrant and fourth quadrant, they are nullifying the third quadrant and second quadrant. If I take from here the dot product, if I'm trying to get the kind of if this is variable, consider the force vector is here, that is constant. Force vector is here, that is constant. Or displacement vector is on x-axis, force vector is varying. So force vector into displacement vector, here it is maximum. If I do exactly opposite, then here it is maximum but negative. They are cancelling each other. But anyway, if force vector into displacement vector we are trying to get, here it is becoming less, 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 less. Okay, or from here if I start, then then displacement vector is in this direction. Here the dot product is 0. Then this is a fixed displacement vector along which we are trying to calculate the dot product. So dot product is maximum. Dot product is becoming less, 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 less again. But all this duration, the dot product is positive. Now from here if I continue, then it will start becoming negative, negative. So this side is exact negative of this side. So to a constant, if I trying to get the dot product of two vector where one vector is constant and other vector is moving. Closed surface means you have to move in 360-degree. That is closed surface. So if you move in 360-degree, the dot product, every dot product will have other side also. So net addition will be nullified by the other side. If someone tries to prove it through mathematics, then line integral. Dot product is called line integral. then line integral in a closed loop will be 0. That is, the force vector dot product of a dot product with a displacement vector along a full path will be 0. So force vector is ai plus bj, or velocity vector. That is a constant vector. Dot product with the displacement vector. Displacement vector is same as d of position vector. At any point, this is position vector. D of position vector is tangent at that point. This is what we are looking. So force vector. So here we are looking, if force vector is fixed like this, then displacement vector is everywhere it is changing. So it is making theta angle with this force vector, and this theta angle will go 0. From here it is 90 degree, then from 90 degree it will come to 0, then minus 90, then full 360 degree it will make. It's the way we gave the example, but we will prove it mathematically. The net line integral is force vector dot product of d of position vector. Position vector is xi plus yj, dxi plus dyj, that is a dx plus b dy. That is the a dx plus b dy. That is the net line integral. Okay, that is the net line integral, and this should be 0. A dx plus y b dy should be 0 for a closed loop. Okay, if someone remembers this energy vector and energy calculus or commercial calculus, if we are trying to calculate a dx plus b dy, then it will result into one algebraic equation that is called g. That's also called potential function. If dg by dx, differentiation of g with respect to x, dg by dx is a, and dg by dy is b, then g is independent of the path. This is called path independent. If I am calculating the dot product of force vector with the line, with the curve, and this dot product, that is force vector dot d of position vector, that is force vector dot d of dxi plus dyj, if force vector is ai plus bj, that is a constant vector, then net this dot product will become a dx plus b dy. Okay, if that is the scenario a dx plus b dy, if this results in algebraic function g and dg by dx is a, dg by dy is b, then g is independent of dx and dy. That comes as a path. It is only dependent upon a and b, or on the velocity or force vector. If that is the call, it is called path independent. If something is if result of this integration is path independent, and we are trying to calculate the integration in a closed loop, means from point A back to point A. Now integration of a dx plus b dy is gx, and that is path independent, then from A to A will be 0. Path independent means net integration dependent upon begin point or end point only. If I am trying to calculate a dx plus b dy from point A to point B, then no need to see it is a circular line, it is a straight line, or whatever. We just need to get the integration and put point A and B. This path is not required, independent of the path. If that is true, then independent of the path is there, then if I try to calculate integration from A and back to A, then it should be 0, because it is path independent and depends upon the begin point and end point. In a closed loop, it is 0. If that is the case, then a dx plus b dy, if this integration is gx, and this gxy, dg by dx is a, and dg by dy is b. If I find any algebraic function for which it satisfies, then this is called path independent, because net result is dependent upon only a and b, not on the dx dy that is considered as the path. Then the result is only dependent upon begin point and end point, and begin point and end point is a to a, means 0. Okay, so anyway, now prove it that you have a gxy, a potential function for which the partial derivatives are a and b. Certainly, if I have a kind of a vector ai plus bj, if I Then if I'm saying dg by dx is a, g is a dx, that is ax plus any function over y, cy, dg by dy, 0 differentiation of cy, equal to b, that is by. So if there is a potential function ax plus by, then dg by dx is a, dg by dy is b. It's possible, it's available. Means this is path independent. Any constant vector is path independent. Okay, in that sense, the net in a circular loop, in any closed loop, the net line integral is zero. Similarly, okay, I don't have exact proof for 2D. So, similarly, if I have a constant vector and I'm trying to calculate in a closed loop the net dot product with the area vector. So constant vector is ai plus bj plus zk plus ck, dot product with the area vector, or dot product d of area position vector, dxi plus dyj plus dzk, that becomes a dx plus b dy plus c dz. Now there is no concept of a potential function here, but this is analogous, similar way description of the dot product of two dimensions. Okay, but in two dimension, if I calculate dp, d of p, then d of p is same as dp by dx into dx. dp by dx, sometimes it is called velocity vector. Velocity vector means it will result into I plus dy by dx j into dx, where y is a function over x, someone can calculate it. If it is for circle, then y equal to square root of a square minus x square. It becomes I plus minus x by square root of a square minus x square j dx. It will come completely into x. Or someone is going for polar coordinate system, then x equal to a cos theta, y equal to b sin theta. In that sense, xi plus yj, dxi plus dyj would become a minus sin theta, a minus sin theta I, okay, plus b cos theta j, dx, this is a cos theta I, that is xi, plus b sin theta j, that is the position vector. A cos theta I plus b sin theta j is the position vector. If someone differentiated a minus sin theta I plus a cos theta j, then that will become a kind of like this. Now, that is the differentiation. That is the differentiation. This is also called velocity vector because we differentiated with d theta. Then if I integrate with d theta, it will give me the net displacement back. This is the analogy out here, whatever it is. Okay, so that is the concept, that 2D concept I can reproduce in 3D. In that sense, AI plus BJ plus Z plus CK dot product D of position vector. So if there is any point P here from center, if I draw a line, that is position vector. That is xi plus yj plus zk. D of xi plus yj plus zk would give me the surface area vector. They may not be in the same direction. Okay, like I have shown that consider this is origin, and this is the point. This is position vector that is going in this direction. But if this is the point, surface area vector will be tangent at this point. The surface area vector will be perpendicular. If this is a surface, then it will be perpendicular somewhere, or if it is a flat line. Consider there is a flat surface. Surface is flat. Okay, there is a flat surface like this, and here is the origin. If this is point P, then this is position vector at any point x comma y comma z. If I differentiate this, then I get exactly surface area vector that is perpendicular to the surface at that point. How it happens? It happens through algebra. So anyway, D of position vector gives the surface area vector ai plus bj plus zk dot D of position vector, that is xi plus yj plus zk. That will come as a dx plus b dy plus d plus c dz. This should be 0, because why it will be 0? It will have theoretically it has same analogy. Consider this: the velocity vector is constant vector, it is along z axis. Then surface area vector, that is perpendicular here. From here, if I take the dot product, then here the dot product will be positive all the while, but other side it will start becoming negative. So dot product with any constant vector to the surface area vector in a closed loop, it will have positive and negative side same. If you add all the positive and negative to a fixed vector, the dot product, it will be same. But someone has to prove it, then he can go in this direction. That is position vector dot the velocity vector dot product with the d of position vector, that is a dx plus b dy plus c dz, or d of position vector is same as d of position vector by d of xy plane into dxy plane. That will come as dp by dx cross dp by dy, that we have seen, that will come as minus dz by dxi minus dz by dyj plus k dx dy. This is also full is called velocity area vector. Anyway, velocity, I am sorry, minus dz by dxi minus dz by dz minus dz by d minus dz by dxi minus dz by dyj plus k. This is called velocity area vector multiplied by the area dx dy. This is full is called surface area vector. Now dot product of the velocity vector with surface area vector is called surface area dot product. Now someone has to calculate full surface, closed surface. That will be in xy plane. What is that? If I take this closed surface and this is xy plane, then I see from the top what is the two-dimensional region over which we have to calculate the integration. X is from where to where, y is from where to where. Okay, if I do so, then I get the net. Now someone can proceed in similar fashion here also. Okay, so that is a kind of assignment that someone can think that how. But someone, for a case basis, we have calculated one example for the sphere, that it is coming as 0. Okay, someone can try for the cubical region or something more on it. If we find the full solution in analogous to two-dimensional, we saw that if there is a potential function for which the partial derivative is the velocity or vector, then it is path independent. If it is path independent, then in a circular loop from same point to same point, it is always 0. But here, same point to same point in a closed surface, this way someone has to proceed upon. Anyway, please don't mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country.